Okay, hi everyone. So we're going to look at the type of problem where you have to make a line, a quadratic, and an exponential through um, two different points. So, sorry, we're in exam review 1 and looking at problem 5 right now. So I'm going to do the work on a separate sheet of paper, but it's considered a quadratic. Sorry. Oh, just consider these two to be the 2 points, 3, 5, and 5, 25. And you want a linear, a quadratic, and an exponential. So our points are 3, 5, and I want to make sure I'm in the frame. Great. And then 5, 25. So just for reference, I'm going to put this roughly at 3, 5, and 5, 25. So even before we start, we know that there's one unique, so we want a linear, quadratic, and exponential. So from here, let's start linear. We know it has to be this. There's only one unique line that will go through both of those points. Right, so pretty standard, we know that 25 minus 5 over 5 minus 3, right? Rise over run is equal to 20 over 2, so my slope is equal to 10. Right, and now from here, I want to encourage you guys to just use this form, sorry, point slope form. Okay, so same x and y are the same. x1, y1 is just either one of these 2 points that you have, and m is the slope we've already solved for. So now I can just say y is equal to 10 times x minus, let's choose 3, plus 5. And I can be done. This can be my final answer. For those of you who prefer slope-intercept form, yes, you can plug this in to y equals mx plus b and solve for b, but this is a completely acceptable form, and it gives me the additional information that I go through to point 3, 5. If you want to check that this turns into slope-intercept form, then y is equal to 10x minus 30 plus 5, y is equal to 10x minus 25. So for those of you that did slope-intercept form instead, you will find that this is the equation you solve for. These two are the same thing. Just like you can move between vertex and standard and factored form in a quadratic, this is just another way of writing a linear equation, and this one's easier because I don't have to expand and solve for b. Okay. Now for a quadratic, can we agree that there are a lot of different ones that go through here, right? Specifically, they can either open downwards or open upwards. So we know there's not one unique one, right? And we can reinforce that by putting on any point, any third point that doesn't have an x-coordinate of 3 or 5, and also is not collinear with these 2 points, and have a 3-point parabola, set up systems of equations, but that's probably more work than we need, right? So what I'm going to do instead is just choose one of these two to be my vertex, right? I can choose my vertex to be 3, 5, and then I go through 5, 25, and that will have to give me a parabola that makes both of those things true, right? So I'm just choosing an easier parabola to make than any possible one that can be made from these two. Right, so from there, just y is equal to a times x minus 3 squared plus 5, right? Vertex form h comma k. And what other information do I have? 5, 25. Right, so 25 is equal to a times 5 minus 3 squared plus 5. 20 is equal to, 4a. A is equal to 5. Right, now from there, y is equal to, y is equal to 5 times x minus 3 Okay, so it's important to note that that is when 3, 5 is your vertex, and you're just coming around like that, right? If you chose the other one, or sorry, 525 to be your vertex, then you would go that way and open downwards. You would still expect your A value stretch to be 5, but in that case, -5. So again, one of many possible outcomes. C, so exponential. So we either, depending on which section you're in, you either have or haven't gotten this yet, but we do know an exponential function looks like this. Sorry, y equals that. Where a is our starting value or y-intercept. You know that it's the y-intercept because when you plug in x equals 0, any number raised to the 0 is just 1, so it's just a times b when x is 0, meaning our y-intercept is 0, a. B is the number that is our base, so if we're doubling every time x goes up by 1, then b is 2. But what we do know is that this is the general form, and we want an a and b such that we go through 3, 5 and 5, 25. So that means that we have a is equal to, 5 is equal to a times b cubed, and the other thing we have is 25 is equal to a times b to the 5th. Okay, so now the same way when we have systems of equations of two linears and we would add and subtract to either substitute or eliminate, we can now divide or multiply. So if this is equation 1 and this is equation 2, I'm going to do equation 2 divided by equation 1, and it's just contained on each side, right? Great. From here, a's cancel out, b cubed and b to the 5th goes to b squared, and I just have 5 is equal to b squared, b is equal to the square root of 5. Right, so now I can go back and say, let's see, either point. So I'm going to have y is equal to a times the square root of 5 raised to the x. Let's pick 3, 5, right, stick with smaller numbers. 5 is equal to a times square root of 5 cubed, and then we have that, so I'll write that as 5 over 1 is equal to a times 5 to 3 halves, right, square root of 5 cubed. So now I'm going to divide both sides by that, 1 minus 3 halves, a is equal to 5 to the negative 1 half, or 1 over square root of 5. It's okay to leave it as this for people who want to rationalize it. That's the same thing as square root of 5 over 5. You do not have to, wow, handwriting is slipping. You do not have to rationalize your denominator when taking the exam, or just generally. But if you want to, that's what it would be. So finally, we just have y is equal to square root of 5 over 5 times square root of 5 to the x. So I know those numbers are a little bit maybe excessively complicated or just confusing because they're all in terms of square root of 5 and 5. There are a few other problems like this. Important takeaways, just to recap, are that there's only one exponential and one linear to go through these 2 points. There's a lot of quadratics. To make your lives easier, probably choose one of those 2 points to be the vertex if and when doing this type of problem.